A typical process industry lockout tagout method is often referred as a single block and bleed. This animation depicts a pump, with inlet valve 1, outlet valve 4, and 2 bleed valves labeled 2 and 3. To conduct a lockout of the pump system, the first step would be to shut down and lock out the pump, then to close and lock valves 1 and 4. This will isolate the process energy from the pump. The next step is to relieve energy from the system. This entails opening valves 2 and 3 to relieve some of the residual energy remaining in the process piping and pump. The next step would be to remove or purge any remaining residual energy. Removal of residual energy can be accomplished by introducing a flush or purge material through bleed valve 2 and out through valve 3. Once residual energy has been relieved, the bleed valves should be locked in the open position to discourage any buildup of energy in the system. The final step would be to test the ability to start the pump, and check to ensure all the valves are secured and locked in the correct position. The disadvantage of this method is that if either the inlet or outlet valves leak by, energy could build up in the system resulting in exposure to personnel. This animation shows a pump with inlet valves 1 and 2, outlet valves 3 and 4, and bleed valves between the inlet and outlet block valves labeled 6 and 7. To conduct a lockout of the pump, the first step would be to shut down and lock out the pump, then close and place locks on valves 1 and 4. This will isolate the process energy from the pump. The next step is to relieve energy from the system. This entails opening valves 6 and 7 to relieve some of the residual energy in the process piping and pump. The next step would be to remove or purge any remaining residual energy from the system. Removal of residual energy can be accomplished by introducing a flush or purge material through bleed valve 6 and out through bleed valve 7. The purge or flush also ensures that the bleed valves are not plugged and holding energy in the system. Once residual energy has been relieved from the system, the second set of block valves 2 and 3 are closed and locked. Then the bleed valves should be locked in the open position to discourage any buildup of energy in the system. The final step would be to test the ability to start the pump and check to ensure all the valves are secured and locked in the correct position. The advantage of this method is that if either inlet valve 1, or outlet valve 4, was to leak by, or not hold, then energy would be seen at the bleed valves, and less likely to expose personnel. The lockout tagout methods discussed thus far have included both isolation and relieving of stored or residual energy. The next two methods to be reviewed are for isolation only, meaning that other means would need to be utilized to remove any residual energy remaining in the system. These methods are typically used when a higher level of isolation or protection may be needed, such as in the case of a confined space entry. The first method to be reviewed is popular in the process industry and is typically used on equipment and vessels being prepared for entry, and is called blinding. This animation shows a pipe segment with a single set of flanges. This particular method of blinding utilizes a slip blind. It is called a slip blind since a blind will be inserted or slipped in between the set of flanges. Installation of blinds must follow first break procedures since it typically cannot be assured that all residual energy has been removed. Wearing the proper PPE, and utilizing line break procedures, the bolts would be loosened as per the procedure sequence, and the flanges spread apart enough to insert, or slip the blind into place. Once in place, the bolts are reinserted and tightened to complete the blind process. Once the blind is installed, a lock and tag should be placed on the blind as a warning to ensure that it cannot be removed. The last isolation technique to be reviewed is referred to as the drop spool method. This animation shows a typical pipe system with a short pipe segment or spool piece installed between two sets of flanges. Just as in the case when using a slip blind, first break procedures must be utilized. Starting at one of the set of flanges, the bolts are removed and the flanges spread apart to ensure no residual energy is present. Then the second set of flange bolts are removed and tested for residual energy. Once all the bolts are removed and tested, the spool piece between the two flanges would be removed, or dropped out, and blind flanges installed on the open flange connections to complete the energy isolation process.